special senses. That's going to be the eye, the ear, the nose. Okay? We'll probably get through the eye today. Look at this. 70% of all sensory receptors are in the eyes. Do you think seeing is a very important human trait? Yeah. Okay. 4 of the 12 cranial nerves deal with the eye. 1 for seeing, optic, and the other 3 is for moving the eye. Who are the other 3 cranial nerves that move your eye up, down, left, right?
Ocular motor, trochlear,
and
abduction.
And abducens, right? To move them side to side. Trochlear, to roll them, and then the other one up, down, left, right. Okay? So, seeing is very important for us. Okay? We are visual organisms. How do you know that seeing is important, besides this anatomy stuff? Where are our eyes located? Directly in the front. Got it? Where are the eyes of your cat? In the front. The eyes of an owl in the front. The eyes of hunters is always in the front. Because where is the prey going to be you're trying to go after? Right there. Got it? And you got to figure out a way to get there. Either you sneak up on it or you run fast. Yes, no? Okay. Rabbits, mice, deer. Where are their eyes located? Laterally. Because 2 things. Number 1, they got a big nose in the front, so that would block forward vision. But where is the enemy coming from? From in front? No, off to the sides. So they can sneak up on you. Yes or no? Then 4? Okay. So as we talk about this, we'll understand more about crossing over and stuff like that. All right. Yeah. This guy can do that. Independently moving his eyes. Okay, here are some of the structures we need to be aware of, and that's why some of the models have them on the front. Okay? Others don't. But here we go. Ready? Okay. Now, your textbook calls this a medial commissure and lateral commissure. The name that we use, because of the other book that we use, is the canthus. Medial and lateral canthus. That's the corner of your eye. Are you with me? So medial here, lateral here. Make sense? Okay. The pupil, the iris. Alrighty. Now, what about, okay, palpebral fissure? Don't worry about all that kind of stuff. Alright, sclera is the white of your eyes. Alright. Now, you see that little piece of meat here in the corner of your eye? That's called the lacrimal caruncle. Okay? I need you to see that you also, see the caruncle, you also have tarsal plates. Now, let's look at your model here. Okay. That's the tarsal plate. It's the part that actually goes over your eyeball. And then this would be the muscle. Got it? The palpebra. Wasn't that on your last lab practical? Yeah, because that's on the muscles chapter, right? Okay. Now, what do you think these 2 things are? These are your lacrimal glands. Oh. Okay. What are your lacrimal glands? Let's do this. That little doohickey right here is your caruncle. Got it? Now, do you see on this plastic model 2 little canals, one coming up and one coming from down? Got it? Those canals are going to pick up your tears. Another name for tears is lacrimal. So these are lacrimal canals, or are they little? Canaliculi, little canals. Got it? So lacrimal canals, okay? And they're going to go into this. Okay? That's the lacrimal sac. And that lacrimal sac, so which eye is this? This eye or this eye? Yeah, over here. Because this is going to run down inside your nose. And that's why if you're crying, your nose runs. Got it? Because all the tears that you're making here get sucked up and go down here. Got it? Which empties in your nose. 10-4? So if you're not making a lot of tears like right now, you're also not having a lot of snot running out of you because we can swallow it. Yeah, every time you swallow me, that's what you're swallowing, folks. Yum, yum. Okay? There is a little tiny hole down here that I want you to see. So, ladies, do you have a mirror in your pocketbook? If you don't, just use mine. Look here. Pull your eyelid down and you'll see the little hole. Do you see it? Just pass that around. Yeah, you have a little tiny hole there. All right? All right. All right. So that little hole is called the lacrimal punctum, like a punctuation mark. It's a little period. Got it? It's a little punctuation mark. Lacrimal punctum. You have one that is superior for the superior canal, and one is inferior for the inferior canal. It's easier to see the inferior one. Just pull your eye down and look. There's a little hole right there. Are you with me? Everybody seeing that? Okay. Now, let's go back here. That carbuncle right here, that little piece of tissue right here, it's here for a reason. So upside down. It's here for a reason. When you are blinking, not only are you sweeping tears across your eyes to keep your eyeball clear of the dust particles in the air that are landing on your open eyes every day, but is water going to dry up? Do you want your cornea to dry up because your eyes are open? Well, what do you think I can cover water with to keep it trapped on my cornea? Oil. Because oil and water don't mix. And oil always raises, you might have to pull it down to see it. Oil always is on top of water. Got it? So, guess who makes the little drop of oil that covers your cornea?
Sebaceous gland.
A little sebaceous gland called the meibomian gland in that carbuncle. Got it? A little drop of oil every time you blink goes across. It sweeps across to keep that water on top of your cornea so it doesn't dry out. Okay? Ooh. Do we do a lot of blinking when we're sleeping? No. So, what happens to all that oil you're making? It becomes the little crusties in the corner of your eyes when you wake up in the morning. That's exactly what that is. Which people say, that's the Sandman leaving sand in your eyes. Because sometimes it's crusty and like sand. Otherwise, it's just kind of mucusy looking. Does that make sense?
So
But that's
sebaceous glands?
it's sebaceous glands, right? Because anything making oil is a sebaceous gland.
No, the little things in the corner. Those are oil?
Yeah, the carbuncle
Okay.
makes, yeah, it's a sebaceous gland. It's called meibomian. Notice it's capitalized. That's the name of the guy who discovered it. Okay? Cool beans? All right. All right, now, how about conjunctiva? Ever heard of that? When you get pink eye, we call it conjunctivitis. Itis at the end of any word means inflammation of. Well, it's the inflammation of a clear covering. There's a clear covering that covers the inside of your eyelids and covers the white sclera. It's clear. So all you see is the white sclera. 10-4? But when it gets inflamed, it turns pink. Please tell me, when you have pink eye, does this ever turn pink? No, because this part of my eye is covered by a clear covering called the cornea. And the cornea does not have any covering on it. Then four, and that's on purpose. Because if your eye totally got pink, wouldn't you be blind? So we'll let the sides get inflamed, but never the front. The cornea has to stay clear all the time, or your eyes are now useless. 10-4? So it can't get infected. And what is an infection? Tell me. Is an infection just bacteria? What's an infection?
Read the symptoms?
Say it again?
Are you saying the symptoms?
No.
Or
Well, we know what the symptoms are, but why do we have those symptoms?
to fight off the
I know. No. Okay, you said fight. Who's fighting?
white blood cells?
That's what an inflammation is. It's your white blood cells attacking the bacteria. Got it? Because right now, is your forearm inflamed? Does that mean it's clean? There's no bacteria on it? No. It's just that the bacteria haven't gotten in and the white blood cells haven't gotten to them to cause a fight. Well, guess what? White blood cells are never allowed into the front of your eye because we don't ever want to have a fight there. Because what do I get? Redness and swelling, and that would distort my vision. And we are 100% visual animals. 10-4? So no animal's cornea ever gets inflamed because they need to have their eyes work. 10-4? Okay. How are we doing so far? On your model, the pink lining on the inside of your eye would be what I would call on your test the conjunctiva. See it? See the pink? Can you see it on the bottom of the lid and on the top of the lid? So that would be your conjunctiva, the layer that can get inflamed. Alrighty. You always sweep your tears from lateral to medial. Got it? Because that's where your lacrimal sac is, going down to your lacrimal duct into your nose. 10-4? This is the way it goes, from lateral to medial. And then it goes into those little canals. Little canaliculi, little canals. Okay. Alrighty, muscles. These are going to be easy to see on the smaller eyes because you see those, but here we only have a piece of a muscle. Are you with me? What are the 4 rectus muscles? Okay, let's see. We have a superior rectus muscle. First of all, what's the shape of a rectus? What does rectus mean?
It's wide and flat?
It means straight.
Okay.
Is this muscle pretty straight? Where is your rectus femoris muscle? Those of us who just had their lab practical. Straight up and down the front of your femur. So that's a rectus muscle. It's straight. Got it? Straight. And where is it located? On top. How about this one? Which rectus muscle is this one? Whoops. Come on. Over here, on the side.
Lateral.
Lateral. And on this side, medial. And underneath, inferior. Does that make sense? Okay. On the big eye model, we just see parts that were cut. Got it? Superior, medial, lateral, inferior. Everybody with me? Okay. But we have 6 muscles. We have 2 other muscles. They go here, at the bottom at an angle, at the top at an angle. And when you pull them, it makes your eyes roll like, oh, there goes Weber talking again. Got it? What do we call those guys? Oblique, because they're coming in at an angle. One is superior, see? And one is inferior. Are you with me? And that's what allows you to roll your eyes. Okay? Some animals don't have that. Your dog and cat can't roll their eyes around. They go up, down, left, right. 10-4. But is facial expression important for dog-to-dog communication? No. How do dogs communicate? They sniff each other's butts and say, hey, do you belong in this pack or do you not belong in this pack? Aren't you glad we don't do that? Kind of embarrassing. But can't you tell if somebody goes, oh gosh, that they're not too happy with you? Yes, no. Okay, here, let me call a mirror up. That's what I see when I look out. Okay? I'm used to it. What is the name of this little loop that this superior oblique goes through to be able to come in at an oblique angle? That little loop is called the trochlea. All right? Guess what nerve goes to that muscle? The trochlear nerve. No. Yeah. The one that lets you roll your eyes. Okay? And that's what they're saying. These are the things they do. All right. You have 3 layers. Open up your eye, whether it's the big one or the little one. Just pop it open. And we'll see this when we dissect the eye next time, on Monday. Is Monday okay that we do our dissections? We'll dissect. We'll finish this chapter in case we don't get to all of it. And then, we'll review maybe, on Thursday or whatever, and then test, right? Wednesday, yeah. Okay? All right. So, the white, thick, tough, protective layer is called the sclera. The brown layer that you see covered in what? What's the brown layer covered in? Blood vessels, yes or no? Is the choroid. Where else have we seen blood vessels called the choroid? Oh, we did this just yesterday. Beat you guys to the stick. The choroid plexus is the pink part that are capillaries that provide the liquid part that makes up your cerebrospinal fluid. So choroid means blood vessels. 10-4. And that's what we have on that brown area. All the blood vessels to nourish and feed the nerves in your eye. Where are the nerves? Where is the sensory part? The retina. So when you open it up, the retina, is all of this light brown part here. Got it? Choroid, retina. Now the retina, I see blood vessels, Mr. Weber, because these are neurons and they're kind of clear. That's why you see blood vessels. Okay? But that's what that is. And when we dissect the eye, you'll see it's a very thin layer of nerve tissue, which you can actually pick up with your tweezers. And that's why sometimes head trauma will cause a detached retina. Ever heard of that? Yeah, because it'll knock this loose. Well, your retina is what you see with. Can you see when that's detached? No. Okay? That's almost like saying, I need these glasses to see you guys. What if it's detached? And now I can't see you. I can tell there's something happening here, but I can't see the detail. Got it? Same thing with the retina in the back. Can't see the detail anymore. So you're pretty much blind. All right. Now we need to understand that in order to keep that retina pushed against the back of the eye, we need a jelly-like substance to be here. And we call that jelly-like substance vitreous humor, or the fluid of life. Okay? Vitreous humor. And you'll see that when we dissect the eye. Does your cornea stick out? Well, there's fluid in here too. And we call this the aqueous humor, meaning the watery fluid. It better be watery. It better be clear. Otherwise, can you see anything if this was cloudy? No. So that's how that works. What is this thing?
Lens.
That's the lens. Now, please, 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 on my lab practical, people always get these things confused. They think the front is the lens and the back is the cornea. No, the lens is on the inside, the cornea is on the outside. Okay? The lens is behind the opening, behind the pupil. The lens. Do you see how the lens looks like it's circle and a circle and a circle? I'm going to ask you to cut the lens in half on Monday so you can see it for yourself. Your lens is made of a crystal clear, better be, protein called crystalline, but it's created layer on layer on layer, like an onion. Okay? And you'll see that when you cut that open next time. How are we doing? Good? All right. Do you see these little lines here? They're called ciliary zones or suspensory ligaments. They're little ligaments here attached to ciliary body, which goes all the way around. We'll show you that when you're cutting open your eye. The ciliary body is this. I'll show it to you right now. Everybody, you got your eyeball open. Do you see this part here that's kind of zigzagged? See the dark part with the little zigzag on it? See it? Yeah, the dark red or dark brown. Got it? That's your ciliary body. It has attached to it, in fact, I'll tell you right now, it's the one that they've painted with little white lines. See it? Because when it's wet, it reflects light, so it looks like it's got little white lines on it. That's what it is. That's the ciliary body. Okay? So the ciliary body is where we have those little ligaments that attach to your lens. Your lens is alive, folks. Your lens moves. How do you know that? Well, look at your hand, then look past your hand. Did you have to focus on your hand, then refocus on the wall? Yes or no? When you're doing that, your lens is being pulled and shaped. Got it? When it's together or getting pulled apart. 10-4? So your lens is thick and thin, thick for close and far vision. 10-4? All right. As we get older, those little things wear out. Those little cilia wear out, those little ligaments. And you can't pull. That's why your mom and dad or your grandma and grandpa might have to have what? Reading glasses. Got it? Now mine are built in. I got bifocals, so far and near. Okay? So I've always had that because my eyes are always messed up. But for some people who are perfect vision, one day you're going to go at a restaurant and go, dang, I can't make out that menu. Lay it over there. Oh, now I can see it. Got it? Because you can't see up close anymore. And you might need reading glasses. But that's okay. What do they cost? $2? You know, do you need a prescription for it? No. Just put on the one that says, oh, that's what I need. Is it a +1, a +2, or a +3? Right? That's all. So you don't have to go to an eye doctor for reading glasses. 10-4? It's like magnifying glasses. All right? How are we doing? Hanging in there? All right. Now, sclera, we got that. Cornea. All right. Ciliary bodies, we got that with the little suspensory ligaments that hold the lens in place. We just said that. Iris is the whole. Iris is the colored part. Pupil is the whole. All righty? Now, this we need to know. Ready? Do you constrict and dilate your pupils? Depending on what condition you're in. All right. And here is what you need to know for your test. When you're in sympathetic, we constrict the eyes. Remember? For close work, for close seeing. And we do that by tightening these circular muscles. Got it? We tighten them. 10-4? Okay. Now, what is your fight or flight? We open sympathetic. We're going to dilate our pupil. We're going to open up that muscle, but not with the smooth. We're going to tighten all of these on the outside. The radial muscles we tighten. Got it? We say, hey, make that smaller, which opens the pupil. And that's in fight or flight because we need to see where the enemy is coming from or look for an escape route to get away from the enemy. 10-4. And that's why I mentioned to you last time, you can see if you have a kitty cat, doesn't matter if she's just hanging out, you dangle something in front of their eyes and their pupil will open up. Because that's their sympathetic, I'm a fighter, I'm a hunter, kicking in. 10-4? All right. How we doing? Hanging in there? All right. All right, now your retina. A very, delicate membrane. You'll see how thin that thing is when you cut open those cow eyes next week. Alrighty? And it deals, mostly I need what vitamin to keep my eyes healthy? Vitamin A. And look at the name of vitamin A. Retinol. You see the word retina in here? Hey, is this a protein or a lipid? Yes. You have 4 lipid-based hormones. K, A, D, and E. Got it? K, A, D, and E are the 4 lipid-soluble hormones. What does that mean? That you cannot absorb them unless you eat them with lipids. 10-4? So, if you're on a fat-free diet, good luck with your vitamins. You're not going to be able to take those into your blood. Okay? And you need them. What else does fat-soluble vitamins mean? That you can overdose on it because your liver stores them. And it can kill your liver if you have too much A, too much D, too much E, too much K. Can you overdose on C or B? No. They're water soluble. That's why people take a handful of C to prevent a cold. Well, you know what? Okay, 1 is enough to prevent a cold. You take a handful, that's probably not a good idea. All you're doing is making very expensive pee-pee. Because water-soluble anything, you pee out the excess. That's why a person with diabetes mellitus pees out sugar, because you've got excess sugar in your blood. You don't have the insulin which says, hey, cells take in that sugar, so the sugar stays in your blood, and your kidneys say, no, I can't deal with that, get rid of it. And that's why you're peeing out the sweet. Remember we talked about the piss ants and stuff? Yeah, okay. All right. So, what do I need to know for our test? Well, do you see cells that are ice cream cone shaped? Those are called cones. Do you see cells that are rod shaped? We call those rods. All right? Do you see a neuron, an interneuron, with the body in the middle and 1 dendrite and 1 axon? What do I call these guys where the body is in the middle, 1 dendrite, 1 axon? Bipolar. Remember, your bipolars are only in 2 places, your eyes and your nose. Well, here are the bipolars in your eyes, okay? And then all of this goes down your optic nerve. Got it? There's your optic nerve heading out. 10-4? Okay. What's this? The optic disc. Well, I hate that name. I like the name blind spot. Why? Because your optic disc you don't see out of. It's your blind spot. It's where you can't see. Alrighty? That's your blind spot. Look at the back of your eye. See if you can find the blind spot. It's very simple. The blind spot is where the blood vessels come into your eye. Look at the choroid. It's on the choroid. Yeah. And it's where all of your nerves come in from. That's where your optic nerves come in before they spread out to be your retina. It's where all the blood vessels go in before they spread out for your choroid. Yes, yes? Well, if you got a bunch of axons coming in and a bunch of blood vessels coming in, can you see right there? That's why it's called the blind spot. You can't see there. But is nature dumb or is nature pretty smart? Where is your blind spot, folks? It's not in the center of your eye. That's the center of your eye. That's the center of your eye. Got it? The center of your eye is where we have what is called the macula lutea, the big yellow, with a very important piece in the center called the fovea, fovea centralis, okay, which is where most of your cones are for clarity and accurate vision during lighted periods of the day. What do cones see? It starts with C. Color. Cones, color. So what do the rods see? Black and white. Which ones are working right now in your eyes and my eyes?
The cones.
Yeah, I can see a blue shirt and a red shirt. Yeah? Your cones work during the day. Who works at night? Rods. This allows you to drive home at night, folks. Are you with me? You get to see where you're going. When you see a parking lot full of dark-colored cars at night, can you tell which one is dark blue, which one is black, which one is dark brown, which one is dark green? No, because your cones go to sleep in the dark. Only your rods work. Are you with me? Have you ever seen movies where the pirate has got a patch over his eye? Arr, you scurvy dog, right? Why does it seems like every pirate have a patch over his eye? Did every one of them lose an eye? Do you realize there's a reason why pirates wore a patch over one eye? Because this one with the patch over it, what's awake? The rods or the cones?
Rods.
Because it's dark. The rods are awake. So when you're up there, shooting at somebody or whatever during a battle, you can see. But when you have to go into the hold of the ship to go get some gunpowder and put a cannonball in the cannon where it's dark, they flip up. And now this eye is ready to see in the dark. This eye is already ready to see in the dark. That's why they do that. Not because they lost an eye. Now maybe in those, Johnny Depp movies they did, but not in reality. They did it so they wouldn't have to wait and adjust to the darkness. It's too late. The other ship is already firing on you. You want to fire first. Remember? You're the Jolly Roger. You're the one that's, Queen Anne's revenge. You're the ones that are going after ships to, take them over and steal all their gold and silver and stuff from it, right? Okay. Pieces of eight. All right? So, in the center of your eye is your fovea centralis and your macula lutea. Okay? Find that in the back of your plastic model's eye. Back of this one, it's right. Take a pencil. Straight from the cornea, straight from your pupil back. So it's right here. His little pink area here, that's your macula lutea. They should have made it yellow because that's what it means, big yellow. But okay, 10-4. It's not where the blind spot is. It's right next to the blind spot. Okay. All right. So, everybody cool? If your retina is intact when you open up the cow eye, you'll be able to see that. Got it? You'll see a little area with a little tiny pinprick dip, little divot in the middle of it, which is the fovea centralis where most of the cones are for color. All right? Because where is our most accurate vision? Right dead smack in the middle. Okay? Now, how many blind spots do we have? 2, one in each eye. Do you see a place where you can't see something? Can't you scan around the room and there's no blind spot? How come I don't see a blind spot? Because our vision overlaps. And so the blind spot of this eye is covered by this eye. The blind spot of this eye is covered by this eye. So the blind spot basically disappears. Do you want to see your blind spot? Okay? Now, this only works if you have two working eyes. I literally had one person, I can't see it. Then they confess, well, I'm blind in one eye. Okay. Do this. Hold your arms out. Put your fingers together. Touch your fingers. Now, look where your fingers come together, then look past where your fingers come together. Do you see like a third finger showing up in between your fingers? Look directly where the fingers come together, then look past it. Do you see a little finger in between your two fingers, yes or no?
Mm-mm. Because I got contacts.
No, it doesn't matter. I got glasses, I can see it.
Oh.
Now, look at me.
Mm-hmm.
Do you see a finger? No, look at me.
Mm-hmm.
Do you see a little finger in between those two fingers? Look at me. Do you see a finger between those two fingers?
A little bit. I think I see it.
Okay.
I see it.
It
Yeah,
should
it's like
look,
very small. Yeah.
but it should look like this. One finger. You should have one finger like this,
Mm-hmm.
and one finger like this, and then you got this in the middle.
Okay, if you pull them, yes.
Do you see it
yes,
now?
Yeah, I see it. Pull apart a little bit.
Yeah, but you can see.
Okay.
You see how that one finger just all of a sudden shows up on this side, which kind of all of a sudden shows up on that side, in the middle between your two fingers? Because that's where one blind spot is and the other blind spot is. Got it? And we're overlapping our vision so that we don't have a blind spot. We're hunters. We can't afford to have a blind spot. Deer and rabbits and mice, they don't care about a blind spot. You can't see a blind spot through one eye. Got it? Because there's no overlap. Why? They got a big old nose in the front. Well, that's because all prey know the bad guy's not coming from the front. But your food is in the front. Hey, does that smell like something I could eat? 10-4? That's why our nose is not this big. Their nose is this big. Got it? The deer need to smell. Who hunts? Okay. What should you do to keep a deer from realizing you're there? You should be what?
Quiet.
Downwind, quiet, but downwind from the deer, because the deer can smell you coming if you're upwind from the deer. Got it? If the deer can smell your scent coming towards them, that's why a lot of hunters do what? Spray themselves with a deer-type scent. Are you with me? Oh, I saw this video. This is probably still up on YouTube. This one idiot, his wife was filming it. This one idiot hunter covered himself in female deer hormone to try to attract a male to come out of the woods. And that male came out and raped him. I mean, it jumped on him and just like, he's going, ah! He's running and she's laughing her head off as she's filming this. Because that big old buck got him. Yeah. Because he's supposed to put one shot. He covered himself. He goes, I really want to make sure those male deer come out here so I can shoot him. And that deer came out and got him. Okay? Because again, smell is very important for a lot of animals. Got it? Okay. Not so much for us, is it? Okay, because our nose is a lot smaller. Okie dokie. Da-da-da-da. See? That's where the blood vessels come in. And you see here, and you bring the axons out. Got it? That's all in the blind spot. All right. Okay, yeah. When you say there was an eye examination, it means like Mr. Weber, you know. Where's the retinal pigment? All right. Uh-oh, what's wrong with this person? Macular degeneration. What is the macula lutea? The center of your vision. Got it? Can you see down the center of the vision here? How about now? Because look at the damage in the center of her vision. Those are dead cells. Got it? There's the blind spot with the blood vessels coming out, but this is dying here. So all she can see is peripheral. Are you with me? Now, the reason I realized this is because when I was in middle school, we had an older teacher, and whenever you called him over to ask a question, because he was kind of hard of hearing, so you couldn't say, hey, what's this? He goes, raise your hand, I'll walk over there. And whenever he wanted to answer your question, instead of going, yes, what's your question? He would always do this. Yes, what's your question? And I'm going like, hey buddy, my face is over here. Why are you looking next to my face? Now I realize he had macular degeneration. He could only see my face from the side of his vision, not from the front. Does that make sense? Is that a good idea to be driving with this condition? No. Okay? And that's why your ophthalmologist will have a computer map what you see. And see, right in the dead center, ain't looking so good. And look how the lines of focus are distorted. Now, straight lines aren't straight anymore. And then what they do with this is to keep that on record so the next time you go in, has it gotten worse? Or is the medicine that we're prescribing helping to stop it? You cannot reverse this because you cannot bring a dead nerve back to life. So damage done is damage done. 10-4? So you want to nip it in the bud as soon as possible, and that's why old people like me get our eyes checked every year. Okay? Just to make sure everything is okay. All right, the cones in the center of the fovea centrale. Let's see, where have I seen fovea before? It was on lab practical number 2. Where have we seen fovea before? Where have we seen fovea before? Isn't that a dip? On my what? Femur. And it's on the head of the femur. So this is called fovea what? Capitis. The fovea on the head. Remember that? This left or right? While I'm sitting here. 100% left. Got it? Yeah, that wouldn't be fun. Okay? Alright. See how a lot of things keep coming back? I won't let you forget things. Alrighty? Alright. Provide high acuity, accurate color vision. Dead smack in the middle of your macula lutea. Alright, there's your choroid with your blood supply. We got this. Alright. Vitreous humor in the back. Aqueous humor in the front. Alrighty. Hey, ever heard of glaucoma? That's something else old people get tested for. Glaucoma is a buildup of aqueous fluid here. Okay? Because you see, we're always making fluid and putting it into this front anterior area. Got it? But if I keep putting it in but I don't drain it out, it's going to build up pressure. You see, you got little tiny drains here to drain out that fluid. 10-4? And that's why you have a glaucoma test to see is the pressure in the front of your eye too high. Because you see, if there is too much pressure, it's going to distort your lens out of the way, but it's also going to push harder and destroy the optic nerve in the back. Is that something we want? No. And that's why we have that glaucoma test. Now, depending on which eye doctor you go to, you might have this, where you put your head up against that little shield and they do a puff of air at your eye, right? Is anybody here remember when it wasn't a puff of air, but a little rod that actually poked you on the eyeball itself? Yeah, that's what this joke is about. See? Oh, we got to adjust it because it just knocked them out. Oh yeah, I'm old enough to remember that. So you put your head in there. Okay, open up your left eye. Go ahead, yeah. Doink. And then you go, oh my God, it hit me in the eye. So, okay, now, switch over and do your right eye. I go, Right, because you know it's coming. You know, you go, I gotta hold it open. You don't want to get hit in the eye with a rod. Now, thank goodness, they don't have to hit you with a rod anymore. They just hit you with a puff of air. And that puff of air comes out at a certain pressure, and then it dissipates, so they can tell how much pressure is pushing back. 10-4? Now, this is the newest one. They put this against your forehead and click a little button. It's a string with a knot on the end that pops up against your cornea. You don't even feel it. Because you put it into, okay, open up your eye, click. She reads it, okay. Open up the next eye, click. I'm going like, it's done? She goes, yeah, I didn't even feel it. I said, how does this work? She turned it sideways, it click, and a little string comes out. It gently pops you on the cornea. Because they need to see. Is that cornea building up pressure and destroying your vision, making your eyeballs pop out too? 10-4? Now, is there a way to help a patient with this? Absolutely. There are chemicals that you can, eye drops, that open up these little drains to help you out. But you don't want to already have all the pressure problems and the destruction of your optic nerve back here before you go to the eye doctor. Does that make sense? That's why yearly checkups is what a lot of them, recommend. Now, those of us who wear glasses, we automatically go every year, don't we? Because we need to see, does this need to be changed? Okay? All right. And your lens is made of what? Crystalline. Got it? All right. Hey, what if your crystal clear lens gets cloudy? We call that
Cataract.
cataracts. Now, does your pupil look black? No, because the light is hitting the opaque white crystal and coming back at you. 10-4? And that's why you're going to see when we dissect, the dead cow eye is already opaque. If you watch those, zombie movies, don't most of them have a white pupil? They're trying to be realistic. Because if you're dead, your protein dies. When your protein dies, it's just like an egg. It cooks. Your liquid, your clear albumin, egg white, turns solid white. 10-4? It's a protein. Albumin, well, this is crystalline, same thing. It changes from not a liquid, but from a clear to an opaque form. 10-4? Okay. So, what happens if a person has cataracts? Do we just say, oh, sorry, you're blind? No. We replace your lens with cataract surgery. There's your lens. That's the new lens with two hooks. They pull back your eyelid, top and bottom, slice into your cornea, and you're 100% awake the whole time. Then they reach in, folded over is your new plastic lens, and when it pops open, these two little hooks, they hook them into the ciliary body to anchor it. Got it? They put a patch over your eye. See, can you imagine your eyeball can be pulled that far? Yeah. Oh, by the way, this doesn't hurt, but this sure does when it starts to heal. Okay? Because it pulled your eyeball muscles that far apart. 10-4? And so they take out the old one and stick in the new one. Now, what did they do before this kind of surgery if you had cataracts? Even in the days of the Romans and the Greeks, they did this. There's no anesthesia, folks. They hold you down. 2-3 guys would hold you down. Another couple of guys would open your eyes, and you would take a scalpel, and you would slice a little hole in the side of your cornea. Slice the hole here, and put in a little stick, and tear your lens away. It's called flipping the lens. We just flip it back. Got it? Put a patch over your eye. Your cornea is one of the fastest healing parts of your body. A couple of days, it's healed. And now your pupil is black again. So you can't see in detail, but you can tell there's somebody in front of me. I can tell it's daytime. I can tell it's later on, it's nighttime. 10-4? That's called flipping your lens. They basically tore it away from those little suspensory ligaments and pushed it back into the back of the eye. Got it? They flipped it down so it'd be out of the way, and then you can still see light and dark. Then 4, and people thought that was wonderful because when you have cataracts, it's completely black. Can't see anything. Nothing comes in, nothing goes out. Does that make sense? Later on, when they invented glasses, you got to wear glasses, but they were this thick. Have you ever seen old movies where the bad guy has these big, thick, giant Coke bottle glasses and their eyes are like enlarged, they really look more sinister than ever? Yeah. Okay? I think one of the characters in Indiana Jones had those kind of glasses. He's the one that grabbed the amulet and it melted a hole in his hand or something. I forgot what it was. That came out in 77. It's probably the last time I saw it. But you might have seen it on TV, right? Okay. But whenever you see an old movie and the guy's got big old thick glasses and his eyes are really enlarged, it's probably to represent that he had his cataracts flipped back. Okay? Right. Don't have to worry about that now. When we have this new lens put in, you don't even have to focus anymore because you can't. Got it? But guess what? It's set at universal distance. This is just as clear as that. You won't even have to worry about focusing. And that's why I asked my doctor, do I need to worry about? I asked her, can I get LASIK surgery? So I won't have to wear glasses anymore. She goes, don't worry about it. In a couple of years, you'll have to get a new lens. You're old enough to have cataracts, so we'll have to put a new lens in anyway. So why have 2 operations? Let's do 1. Thank you. Good. Thanks for reminding me how old I am. Okay. What is light? Packets of energy called photons. That's why we call taking a picture photography. Graphy, a graphic representation of photo, light. A picture made of light. Okay? The only light we see is this, folks. That's the rest of the universe. All we see is this. Visible light, which when you shine it through a pyramid-shaped prism of glass or plastic, you get the rainbow. Got it? Why do we see a rainbow in the sky?
The light reflecting off
The
the
light reflects off, droplets of water
mist.
that are still in the air after a rain shower. And what's the cool biblical story? I know.
God would not flood the earth again.
God said, after the big rain for 40 days and 40 nights, he showed a rainbow and he said, that is my promise, I'll never flood the earth again. And that's why we do tend to see a rainbow after a rain, because there's still droplets in the air that will refract the light. Okay? All right. So, what do I need you to know for your test or just for general life? Okay? General life. Have you ever heard of, we'll go this way. Ever heard of infrared? Yeah, infra means below. Below the color red, which is the lowest energy. Lower than infrared is microwaves. Got it? It better be. Do you realize how many microwaves are going through your body right now? What you talking about, Willis? Well, you have a phone. Yes? Is your phone plugged into a wall somewhere? How are you getting all that information on that piece of plastic in your hand? It's being sent from a microwave tower through the walls, through the air, through your body, to your phone. Are you with me? It's a low energy form that goes right through your body. Now, what are the consequences of being bathed in microwave energy 24/7? We don't know. We don't know. But there has been more cancer than ever before, but we don't know. Ask your parents. When the first handheld phones, with no wire, going to the wall. When the first handheld phones were created, there was a warning after several people got cancer. They said, when you're holding your phone to this side of your head to talk, switch sides every once in a while. Because there were cases of people who held their phone always to the left side and got brain cancer on the left. Or only held it on the right side and got brain cancer on the right. Now, do we hold our phones next to our heads that much now? No, we have it down here, right? Beep, 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 right? So there's not that much of a brain cancer situation. Hey, anybody want to sit in a microwave, have it closed up and turned on? See, there is energy in there. What is a microwave oven? What kind of energy and how does it work? You don't make a phone call from there. How does that work? How does it heat up your food? Anybody know? And this is the reason why you want to close the door before you can turn it on. In fact, you can't make a microwave that runs with the door open. Have you noticed that? It can't work. That's on purpose. Because a microwave is set at a special wavelength that makes water move. It hits water molecules and make them move. Got it? That's why you can heat up soup but not make toast in your microwave. Are you with me? It's not an oven. It doesn't use heat. It uses an energy that makes water molecules move. Well, do this. Are your muscles getting colder or hotter?
Hotter.
When you move the water molecules really fast, they get hot. That's why you can heat up a bowl of water, then add dry rice to it and let it soak up the water. You can't put in dry rice into a microwave and heat it up because there's no water in the rice. Are you with me? There's no water in toast. Are you with me? You have to have your food has to be watery. Now, what is wrong with turning on your microwave with the door open? We're full of water. Do you want your eyeballs to pop because you looked in? Don't lie. How many people look and watch the little cup of coffee or whatever go around and around? Yeah. Do you want to go blind and have your eyes just boom? No. You see, what's in the door window? A mesh. Got it? It's called a Faraday cage. The holes are smaller than the wave height, the amplitude of the wave. So when they hit the cage, they bounce back. They don't go through. And why is that? Because the first microwaves were made with a solid door, and people kept opening it up. How many of you have an oven that you can't look into? Exactly. Most ovens have a glass window because you want to see, is my turkey ready? Yes or no? People want to see in the microwave. So they say, okay, let's make a Faraday cage to keep, we can see, there's light in there, you can see, and we can not get our face blown up and our eyeballs popped because of the water heating up. 10-4? Okay. So, anybody watch the movie Gremlins? Didn't one of the ladies throw the gremlin inside the microwave and turned it on? He went boom, right? Because he's watery on the inside, right? That'd be you or me if we were in a microwave. All right, and then the lowest energy of all our radio waves, which we have been bathed in for 150 years now, ever since the radio was invented. 10-4? Okay. What about this? Well, Roy G. Biv, right? Red, orange, yellow, green, blue, what? Violet, indigo, dark blue, and violet. Violet is the highest energy. So what is ultraviolet? Above violet. Okay? Ever heard of UV radiation? Ever heard of UV light? Yeah, we call it black light. That's just ultraviolet light without the rest of the colors. Higher energy than that are X-rays. X-rays go right through your body, but they're stopped by your bones, and that's why we can take an X-ray of a broken bone. But you can't diagnose somebody's heart because it goes right through that tissue. Does that make sense? Is it a good idea to be an X-ray technician and just stand there and hold your patient's hand while the X-ray machine is working? Anybody ever had an X-ray made? Where's the technician?
The other room.
They left the room. In fact, that room is covered in lead. There's lead walls because we don't want the other nurses and doctors in the rest of the hospital to get X-ray poisoning. Got it? Is there a window on the door to that room? Yes, they can make sure you're okay in there. And guess what? That's leaded glass. That's silicon dioxide with lead impregnated in between each silicon molecule. Because X-rays don't go through lead. It's too dense. 10-4. And if you had an X-ray done, do they put something over you? Is it kind of heavy? That's a lead apron. What are they trying to cover on you?
Your organs.
Yeah, but mostly what, boys? Your gonads. Because you're constantly doing mitosis to make more sperm. If you have energy hitting those DNA molecules, it might mess them up. And you make a copy that's incorrect. We call that cancer. Ladies, do they put something over you too? For the exact same reason, so you don't damage your eggs. We don't want that energy. It's coming through your cells, and if it hits your DNA, it might change the shape. Instead of T with an A and a C with a G, it might knock it out of whack, and now all of a sudden a T is with a C and a G is with an A. Is that going to make an accurate copy? No. Got it? So X-ray technicians, yeah, they found out the hard way. After 10 years of an X-ray technician, you died of cancer. Then they put two and two together. Oh, wait a minute. Even though that X-ray machine is pointing straight down at this guy's arm, it scatters in the room. So that's why the X-ray technician is always outside, and then remotely, beep, it's a one quick open close to get that X-ray. 10-4, but they're never in the room. You only get exposed once. What if they have 15 patients 5 days a week? They're going to get exposed a lot. 10-4, that's why they step outside. All right. And what is the most energy? Gamma radiation from nuclear fallout. Got it? Either from a nuclear bomb or a nuclear power plant. Got it? Well, that was all new stuff. Because remember the Hiroshima bomb? Ever heard of that? Okay. So when Stan Lee at Marvel said, how am I going to turn this mild-mannered Dr. Bruce Banner into the Raging Hulk? Let's have him be accidentally at a nuclear testing site and get hit with gamma radiation, and he became the Hulk. No, when you get hit with gamma radiation, you're going to be dead. If you're close enough, you're going to get fried. And if you're far enough away, you're going to die of cancer. Okay? Do you think that's why people are, I can't wait for the next World War? No, because we now know everybody's got a nuclear warhead. The Third World War might be the last one. Everybody starts chunking nukes at each other. There's no coming back from that. Okay, so we want to kind of not have war. All right, infrared. Animals use infrared, folks. Just like we can use infrared to see a deer in the woods, or the Predator could see Arnold Schwarzenegger. Anybody heard the Predator movie? He saw in infrared. And here, look, that's a caterpillar, which is cold-blooded on somebody's hand, which is warm-blooded. You see the difference? Snakes use this, especially what we call pit vipers, like a rattlesnake here. See, 2 eyes, 2 nostrils, but 2 pits in their front of their cheek. This is what they see. The whole world is dark except for the warm-blooded mouse. And that's who they eat. Got it? Rattlesnakes don't go after cockroaches. They're cold-blooded. They don't eat frogs. They're cold-blooded. They go after warm-blooded creatures. And that's why I see you, and now, chomp. Gotcha. Then 4. But why do rattlesnakes bite us? If you step on them, folks. Do you think a rattlesnake sees something 10, 20, 30 times bigger than it is at lunch? That's why, what do they do to warn you? Shh. Don't they? Because they're more scared of you than you are of them. They don't want to bite you. It's when you startle them. You know, you step on their tail or something, all they got to do is reach back. 10-4? So be careful when you're in the woods, especially here in South Carolina. We have plenty of timber rattlers. Okay? Some of them get to be 8 feet tall, 8 feet long. I know, I had one of those near where I live. I live out in the woods, and we live off of a dirt road, and one morning I'm in my car getting ready to go to work, and I'm going like, darn, a big log fell across the street. And as I got closer, the log moved out of the way. It was an 8-foot timber rattler this big around. Now, it was down the street, it wasn't in my front yard, so I didn't run back, see, I had to go to work, so I just went on. He was sitting in the ditch next door, all curled up, in a pile about that big. All right, ultraviolet. Do you realize animals see in ultraviolet? In particular, honeybees. What you talking about? Here. This is what we see. Honeybees see this. We see yellow. They see white with a bullseye target. See? They see blue or bright yellow in the center of the flower, which is where the nectar is that those bees want to lick up. 10-4? That's why bees don't land on your shirt if you got flowers on your shirt. Why? Because it doesn't give off ultraviolet radiation. They can't see it. Got it? A plastic flower. Yeah, I can see a plastic flower. They can't. It's all black like the rest of the world. A dead flower is black like the rest of the world. Only a live flower glows in the dark. See, the rest of the world to a bee is this. That's why bees can find flowers 5, 6, 10 miles away. Because the whole world is black except for those colorful flowers over there. That's what the perfect pollinators. Got it? As they're running around in the center of the flower, they're getting their hairy bodies covered in pollen, which is the sperm of a flower. That's the male part. And when they fly to the next flower, they drop those on the female part, helping to fertilize the next crop. Are you with me? All right. Oh, look at this. Can you see skin damage on her under white light? Nope. But we can see it under ultraviolet light. Feel the skin damage? Okay. All right. Refraction. That means we are going to bend the light. Is this a broken pencil? You've seen this since you were elementary school, right? So you showed you that. That's because light coming through here is bounced back, but light coming through water is bounced at an angle. So this looks bigger and bent over to the side. Alrighty? And that's what your lens does. That's exactly what your lens does. Notice, what's at the top? Lavender and orange. Now, what's at the bottom? Lavender and orange. Is it lavender then orange? Yeah. Now here's orange then lavender. So it flips it upside down and backwards. Believe it or not, folks, your eye, right now, what you're seeing, okay, in the back of your head, the ceiling is down here, and the floor is up there. Got it? And this is my, this will be on the left side, and then it'll be on my right side. To you. How come that's the ceiling, that's the floor, this is my right, and this is my left? Because your brain flips it over to make it useful to you. Does it make any sense to a hunter that, okay, the prey is actually up there, but they're actually down here? Does that make any sense? Well, guess what? A professor wanted to prove this point, that your lens flips everything, but your brain unflips it. So he volunteered. Got it? And what he did is he had a set of glasses strapped to his head that he couldn't take off that flipped everything upside down and backwards. Okay? And he said, I'm going to wear this until my brain flips everything normal. Took about 3 months. Can you imagine for 3 months trying to walk down the stairs and your feet are up here? Trying to pick up something and your hand is over here. You're going like this, but the glass of milk is over there. Can you imagine the headaches you have? Well, guess what? After 3 months, he could walk. He could pick things up because his brain flipped everything back to right side up and back to ipsilateral. Got it? And he said, okay, I proved my point. Now what did he do? Took it off and everything's backwards again. Didn't take 3 months to get that. It took like 2 weeks to get it back to normal. But that proves that's what your brain does. Okay? It has to, because your lens can't do it. Your lens flips things upside down. Alrighty. The accommodation is changing your lens to close and far away. Alright. Now, here are some cool words. Myopia. Myopia means nearsighted. That's me. I can see perfectly fine. In fact, I like to read a book without my glasses. Okay? Because that's not good. But I can't see a darn thing over there. Don't make me drive without my glasses. Because I'm going to get in an accident. I can tell there's students here, but I can't tell who it is. Does that make sense? Because I don't have any focus. Farsightedness, hyperopia. That means you can see far away, but you got no idea what's up close. Alrighty? Ever heard of astigmatism? This means either your cornea or your lens is football shaped and not round. So things get distorted at an angle. Okay? And you can get special glasses and even special contact lenses to fix that. It's amazing. I used to wear contact lenses when I was younger, and I was good looking. But as you get older, your eyes get drier, and it's a lot more difficult to have contact lenses in your eyes. So I've had glasses for the last 15 years. Okay, now this is the normal eye. Test question. Which eye is the normal eye? A, B, C, D, E. Okay, the emmetropic eye is the normal eye. Those of you who don't wear glasses, don't wear contact lenses, and still see 20/20, what does that mean to see 20/20, by the way? You see at 20 feet what you're supposed to see at 20 feet. Got it? If you're 20 feet away, that's what you see. 10/4? Okay. Look, see how the light comes in, it gets bent, refracted, but where it comes to a point where it's in focus is directly on your retina, where it's supposed to be. That's why this person does not need glasses. Emmetropic eye. Now here, this is the myopic eye. This is my eye. My eye is too long because when the light comes in, the focus is here. So by the time it gets to the back of my eye, it's out of focus. Got it? The focus is where it goes like this, but not where it goes past it. Got it? So I need glasses that spread out this thing so that when it does come back, it's landing directly where it needs to be, and now I can see. Okay? That is your myopic eye, too long. This is your hyperopic eye, too short. Light comes in, and by the time it focuses, it's past here. So what you see is out of focus. So they need a different kind of lens to spread it out and narrow it so that it lands right on the retina. 10/4? Now, which one of these two can be corrected with LASIK surgery? You can't do both. This one. Because LASIK surgery shaves away part of your cornea to make your eyeball shorter. A laser cannot add, not your retina, but your cornea. You can't add to your cornea with a laser. You can cut away from it, but you can't add to it. Yes, ma'am.
So why do people get LASIK surgery to fix their vision?
Because it makes your eyeball shorter, and then you can see without having glasses. My sister had that done about 20 years ago. She loved it. Okay? But that's what it is. Even my eye doctor had it done. That's why I asked her, I said, yeah, am I a candidate for it? She goes, nah, you're going to need new lenses in a couple of years anyway, so just keep wearing your glasses, you'll be fine. I mean, why pay for 2 operations, right? Okay. See? Rods, cones. Okay. How does a rod work? Ooh, it's almost done. How does a rod work? Now, I'll ask you to try this tonight or sometime this weekend. Okay? Try this weekend. When light hits a rod, it releases a chemical called rhodopsin. Rhodopsin. Rhodo means rose and opsin is vision. Rose-colored glasses, have you heard of that? That means, oh, you're seeing everything is so pretty. No. Your eye actually uses a pink chemical to see in the dark. Alrighty? Now, we don't recognize that because it's not sudden. It slowly happens, so you really can't tell. That's why I'm saying try this weekend. I can't do it here. We have no rooms that are completely light closed. Got it? There's always light coming up underneath the bottom of the doors, even in the bathroom. Okay? I guess because they want to, they want to make sure. Is the lights on in there or the lights off in there? 10-4? Okay. So, at your house, maybe the bathroom might be the darkest place. Don't do it during the day. Do it at night. Okay? So, try to get to the bathroom without lights being on. So your eyes are already in dark mode. 10-4? If not, close the bathroom and just wait until your eyes are perfectly adjusted to seeing in the dark. 10-4? So is it who's working?
Rods.
The rods. Then, with your hand on the light switch, okay, look in the mirror and flip the lights on for a second. Boop, boop. On, off. Got it? And guess what you see in the mirror? Your face and the rest of the bathroom in pink. Got it? In fact, you can actually turn your head and you see the whole place with a pink outline, but only for a few seconds, then it's back to pitch black. But it's really cool. I did this all the time in high school because they actually had dark bathrooms. So I guess to keep the marijuana smell inside. I'm just joking. But you see that pink. It's really interesting. All right. And gee, I wonder how that works. Well, let's see. Light hits it. We launch a G protein, make a second messenger system, and that's what allows us to see. We call this transduction. Why? Because we're transforming optic to electrical. We're changing light to a chemical, which then makes it into an electrical signal. 10-4, when you change from one form of energy to another, it's called transduction. You'll see this when we cut open the eye. We don't have this. Only animals have this in the back of their eye. Our eye is just like your plastic model. It's kind of brown with the red blood vessels in it. Got it? When we take a picture and you get red eye on some of the flash, what are you seeing? The blood vessels in the back of your eye as seen through your pupil. Take a picture of your cat, it's never red. What color is it? Like green or something, right? That's because animals have this colorful tapestry behind their eyes. Why? Because animals don't know anything about flashlights. See, the Lord gave us a brain to come up with something to see in the dark. Animals have to be able to see in the dark. So they have this in the back of their eye. Have you ever seen a video or a TV show or a movie where the character has got on night vision goggles right? What do you see? Everything's green. You know why? Because they painted the back of the scope with green crystals. The light, very light, just some stars, hits that, and as it bounces around, it makes the whole area look green. That's what animals have. They have little colorful crystals in the back of their eye in a thing called a tapetum lucidum, a colorful tapestry, and that picks up starlight, moonlight, got it? And it bounces back and forth, so now they can see. So if you're a night hunter, you know where the prey is. If you're a prey, you know where the hunter is. You've got to be able to see at night. Have you ever heard of deer in the headlights? Why do deer always stop in the middle of the highway when they see a car coming? Because now the light is blinding them. Their eyes are used to seeing starlight for their environment. Now, these two big headlights, and it startles them, that's why they stop, and boom. Does that make sense? That's why there's always a dead deer on the side of the road. Does that make sense? You're startling them to the point that I can't see. I don't know what's going on. Do you want to finish this next time? Yeah, we can. We've done enough to do our dissection. Cool enough? All right, we'll stop right here at 3D.